This is a lecture on 10-3, coefficient of determination and standard error of the estimate. And I'd like to point out a few things in 10-2 because the lecture was only on the calculator. So as far as 10-2, what we're doing is we're doing the least square regression line. It's the method of finding the line of best fit. It's called the least square regression line. It's going to be labeled as y prime, and we need a plus bx. We need this form. Now, as far as 10-3, what we're looking for is the coefficient of determination, and that's r squared. The definition is actually covered in a definition page under chapter 10. And what we're doing is, it is really the r that you're physically squaring. And what it's going to give you is, it's going to give you a percentile or a proportion of points that are explained by y prime, by your least square regression line. The standard error of the estimate is labeled in the book by S sub EST, like this. It is given by the formula square root. You need to add up all of the differences between y and y prime squared divided by n minus 2. And in your calculator, it's going to be the labeled letter S. So we don't want to get the S and the S sub X and S sub EST confused. So what we're going to do is we're going to label it the way the book does. S is your standard deviation of a sample, and S sub EST, that's the standard error of the estimate for the linear regression line. Now, if you know that r squared is a proportion of points or a percentile of points that are explained by the least square regression line, the coefficient of non-determination has to be 1 minus the r squared, so the rest. So if 90% are explained, the other 10 have nothing to do with the line. So that's what this means. So 1 minus r squared will calculate the coefficient of non-determination. And the last thing in 10-3 is something called residuals. The residuals are calculated by taking the difference between y and y prime. On your calculator, you'll actually be able to get that list with just a push of one more button. So what we're going to do is, on the next video, I'll show you a calculator version.